So welcome to this session, question 2. So question 2 part 1, synthesize 2-methyl 1-phenyl prop 1 in using a Witting reagent. Begin by using the Witting retrosynthesis analysis. So we need to show everything. So for us to show everything what's happening, we know that for us to make this one, we need the reactants. We need also the reagents to form the products. So the product has been given as um, uh, this 2-methyl 1-phenyl prop 1 in. So how to draw this one? We know that we have a prop. A prop has 3. Then we also have a methyl on carbon number 2, and also we know that we have a phenyl group a phenyl group a phenyl group attached to it. Okay, so this, and there is an in there. Okay, so this is a structure we are going to make. So which reactants rather are we going to use? Reactant and reagent. So we can see from here that for us to make a Witting reagent, we need to get one as an aldehyde and one as a Witting reagent, which we're going to make as a Witting reagent. So if we cut from here, we are going to make the ring structure first in this video, this structure to be our aldehyde. So if we cut from here the double bond, we get this as an aldehyde, and the remaining part we use it to make an aride. So if we are to cut that, we're going to remain with this. Okay, then you have an aldehyde here, and of course the double bond. So this is the part which is here. Then you're remaining with the other part, which is this. So we're going to use this to make it into an aride. So to show the retrosynthesis of this, we are going to react it with this reagent, this plus the reagent we are going to use is chlorine in presence of light and heat. Okay, so this is a free radical reaction, free radical reaction. Right, so under radical reaction, we know that once heat comes here on the chlorine, heat or light, it's going to cleave these to form. This is a step of initiation step, the initiation step to form the radical of chlorine plus another radical of chlorine. This is the first step. Then second step, you're going to have now your isopropyl to react with a radical. Okay, so once you react this with a radical, this will come there and attack the hydrogen which is here. Mind you, then we are going to form this, the chlorine there. Yes, Then there are a lot of possibilities that it can attack from here, it can attack from here. Then we have also this is the propagation step, propagation. Then we also have the the final step, which is the final step is to react the chloride radical plus another chloride radical can form now what we started with, which is chlorine. All this requires heat. For this process requires heat. It's an endothermic reaction. So once you form this, as we are only interested in this, yes. So this will be our products. We're going to have, once we react this one with chloride in heat and light, will form this. Now this is going to react now with an alide. An alide, something which is looking like this. The phosphorus attached to the three phenols. So this one will attack by a backside attack and kick off that one. Hence we are going to have this as our product, intermediate product. So once we have this, the next step will be to react this one now with a tertiary butyl, yeah, which is going to deprotonate. There is a reason why we are going to deprotonate that. So we are going to use a butyl. Okay, so this is a butyl with the negative charge there. Yeah? So it will come and get the hydrogen, which is here. It gets the hydrogen, then here we have lone pair of electrons. Then the product we are going to have will be looking like this. Here we have lone pairs, then here we also have that pH3. So what is going to happen here now, this is going to react now with the aldehyde we formed, plus the aldehyde, which will be that. So now what is going to happen, this lone pair of electron will come and attack from here, will come and attack here, opening the bond, that. Then the oxygen now will come to bond with the phosphorus. Let me show this step first. We're going to have a structure looking like this. Okay, we draw the way we see it. The oxygen there, then here we had that carbon which was here, this carbon, right? Then this part was having the pH3, like that. We are drawing it the way we are able to see it, so that we don't just come up with a product, right? So there is an interaction which is going to happen between the oxygen and this phosphorus, which is going to be like that. So now we can draw that interaction as like this. As in like this. So we have this attached to the oxygen. The oxygen is attached now to the phosphorus and the pH3 there. Then the phosphorus is attached to the carbon which is here, the one which is here. Then this one is the one which was on the oxygen, is attached to the carbon which is on the oxygen, this one going to there. Then on this carbon we have these two, these two, these two, these are the one which are here. So what is happening now, find out that the bond here, there will be a breakage of bonds. This bond will break on here and this bond will break on there, hence forming the products, this one. So this one will be a scene addition, a scene on the same side, like that. We have drawn this line. Let me use a different color. Alright, this is a bond we are drawing. Okay, this one is the bond which is here. Then we're going to draw this one which is here. So here the electron has fallen here, so there is a double bond here which is formed. Then we draw this the way we see it, this one, then another one, this one goes up. We have formed our product. This was our product they wanted us to form, plus now the remaining structure which is PH3, now double bonded to the oxygen because of the falling of electrons on this. So our interest was in making this. This is how it is made. So part 2 of question 2. For part 2 we had a series of reactions which was saying give structures for compound A to E. Okay, so follow it the way it is. Mind you, the reaction you have from doing, you can even do it the other way around. You can start with this ring structure, the ring structure to be your, to make it as an alide, then the remaining part here from the double bond you make it as your ketone. It will be the same thing. Okay, so now moving to the part 2, give the structures for compound A to E. So let's follow it. Right, right. Part 2, it's part 2. So we were given the cyclohexanol, the structure cyclohexanol. So the structure for cyclohexanol, draw it. They reacted it with Jones reagent H2CrO4 to form product A. So let's draw cyclohexanol. Cyclohexanol, the secondary alcohol mechanism. Okay, so cyclohexanol react with the sulfuric, the hydrogens, the chromate acid. So the chromate acid, what it does, it oxidizes primary alcohol to aldehyde and secondary alcohols to ketones. Now in this structure, this is a secondary alcohol, so it will go direct into a ketone. Then the mechanism, will draw this there, there. It's a structure for chromic acid. So the chromic acid, almost in Jones reagent, they also use sulfuric acid. So it's to protonate this oxygen. So what is going to happen is the oxygen there will attack the chromium there, then it opens the bonds there to form this. This is called a chromate ester. Alright, then the chromium there, start with the OH, double bond oxygen there, the OH, and another OH here. And so what is going to happen, the acid, mind you, just protonated the oxygen on the chromium here. So this oxygen becomes full of electron, so we're going to deprotonate this one, and there is a hydrogen here. So the acids HSO3 minus comes to get this, and this one oxygen becomes then we are going to have this chromate an oxygen there. The oxygen is bonded to a chromate. This is what is going to happen. Or we can use here, there is a hydrogen. So what is going to happen, we are going to use water or a proton to get a proton there, to get this hydrogen, and the hydrogen is going to send its electrons here, and the oxygen is going to break the bond to there. Hence you have this ketone, a good ketone. That's the work of a Jones reagent. Once electrons falls here, they fall here. So you're going to form a double bond to an oxygen. Then the oxygen will break the bond to here. Then you have that. So we are interested in forming this. This is a Jones reagent reaction. So a secondary alcohol reacting with a Jones reagent or chromic acid will form a corresponding ketone. This is a ketone we have formed as structure A. Then the next step, we're saying structure A, the same structure A we have formed, reacted with which is CH3 MgI. So this is called a Grignard reagent. A Grignard reagent will add the CH3 to this functional group. So this CH3 comes here, opening this thing. Hence, we are going to have this in the first step. We are going to have something looking like this, oxygen there, and the added CH3. But this one is like this. So in the next step, they said they reacted this. In the next step, number 2, they reacted with a proton. Alright, so this one came to attack here. Okay, then here the oxygen will come and get this proton there, and we are going to have this well looking structure, which is that, and a CH3, a secondary. This will be now our structure B. This was structure B. The Grignard reacts to attack the double bond. Then we open the double bond there, and the oxygen comes to deprive the hydrogen. Then we form an alcohol there. Okay. Then let's move on to form structure C. So it's the same structure we formed. Now reacted with an acid. Reacted it with an acid, hydrogen chloride. So what is going to happen when we react with hydrogen chloride? Every time we react something with hydrogen chloride, we are going to protonate. Yes. So this will be Okay, show properly here. It's going to go for the oxygen, which is here. The oxygen will come and get the proton from the chlorine, and this will go there. Hence we have this. This is water, formed water plus a chloride ion. So what will happen? The the water is now a good living group. Once it leaves, mind you, the acid was just a catalyst. Here we had oh, sorry, the structure, we have changed the structure. The methyl was here. So this one leaves as a good living group. This one leaves as a good living group. Then okay. So here we have lone pairs of electrons. Then remaining with this CH3. So we can either get a hydrogen from here, so that the chlorine comes to get the hydrogen, and the electron will fall on here to form this. Now CH3 with a double bond there. So this is now our structure C. Okay, so you may be confirming by writing the molecular formula with the structure. You find that this is the same structure we are having. Okay, move on to structure D. For us to make structure D, we are making them from what we have, which is this one, the CH3. So now we reacted it with ozone in the first step. So we know what ozone does. It will go and cut the double bonds. Comes here to cut. That is what we are going to do. So when we cut there and add an oxygen, that's ozone. So there we draw first the way we see it. Then it comes like that, like that, like that. Then if we cut from there, we have an oxygen, another oxygen there, this. So this is what we see. Now if we were to draw it in a straight line, draw it properly, we number the carbons: 1, 2, 3, 4, 5, 6, 7. So we'll draw a 7 chain: 2, 3, 4, 5, 6, 7. So on carbon number 2, we'll put the ketone there. This is a ketone. On carbon number 7, this is 1, 2, 3, 4, 5, 6, 7. On carbon number 7, we put our aldehyde. So this is the structure. This is just the same. We have just expanded the ring. Yes. Then in the we react. They also had DMS, and this DMS. This one cuts, and we add the hydrogen through DMS. And this is now our structure D. Okay. So now let's draw the last one, the last structure. So from structure D, 1, 2, 3, 4, 5, 6, 7. This was our structure D. Right? Then they reacted it now with silver oxide in presence of a base. So this is a Doran's test. A Doran's test is always positive to aldehydes and not ketones. So it will convert the aldehyde into carboxylic acid. So this part is the aldehyde. This is an aldehyde, will be converted, but this will be unaffected. So we'll draw it down here. 2, 3, 4, 5, 6, 7. So this aldehyde now will be converted into a carboxylic acid with a ketone. This is our structure E. That was it with question 2.